All right, so this is the last summative for the fall of 2019 in Algebra 2. And let's make it a good one. We have a couple of repeated sections here, so some of you are going to have a chance to up your score just because you're going to do better. And then others, you already were doing amazing at these, so we are going to offer you some bonus questions on this test. So make sure that you give them a try. There's no harm, no foul, just try them. So here, this is a repeated section. Third attempt at completing the square. Here we go. So how do you find C, the value of the blank? Well, what you do is you take the middle term, which is 20, positive 20. You cut it in half, and then you square it. So that would be 10 squared, so 100. Now, if you go to write it in factored form, the pattern for the factor is, usually it's an x, but whatever the first variable is, and then plus half of your b term, so b cut in half. So our b was a positive 20, so cut that in half, and you're going to get an x plus 10 quantity squared. So make sure you watch your signs on that problem. If your b term is negative, that means your factor should be negative. So I'm going to do every other question like we always do on the review, and then you guys are going to finish the other ones for homework and for extra practice. We're also going to ask you to solve by completing the square. So solving, you're allowed to touch both sides of the equation. So the first thing we're going to do is we're going to rewrite it by moving the 8 over, and while we're at it, we're going to leave a blank. So the 8 is being moved over because we're going to subtract the 8. And then because we're on opposite sides of the equation, you're going to add a blank to both sides of the equation. So speaking of the blank, you find that by taking negative 10, cutting it in half, and then you're squaring it. So that would be a plus 25 on both of our blanks. That allows you to now factor your trinomial. You created this perfect trinomial, so this factors into x, and then half of negative 10 would be negative 5 squared. And then negative 8 plus 25 is a 17. So then your next step would be to square root both sides. Square root, and of course I wrote way too big. So here we have x minus 5 equals, now because 17 doesn't break down, that's good news, that means less work for you, but please don't forget the plus or minus. So we have positive and negative the square root of 17. So then our last step is to add the 5 over. So x equals 5 plus and minus the square root of 17. The answer key is on the back of your review packet. I'm sure there's at least 2 mistakes on it, so apologies in advance. I think I even wrote an apology note to you at the top of it. All right, let's try this next section. Same section, new topic though. Now we're going to write in vertex form, which is going to look like this. Okay, x minus h quantity squared, and then plus k. But I want you to use modified version of completing the square. In the modified version of completing the square, you don't do any work on the left-hand side of the equation. All of your work happens on the right side. So we're going to keep the x squared and the 4x term together, and we're going to leave a blank so we can complete the square. The plus 3 can't go anywhere, so we just kind of shuffle it off to the side. But because we're on the same side, we need to make sure that this other blank is a subtraction, because this is the same side of the equal sign. The blank is found the same way it always is, so you take the 4, you cut it in half, and then you square it. So that's going to give us a 4. So we're adding 4, and then a couple seconds later we're subtracting 4. But the reason this works is because now this factors into x plus 2 quantity squared, and then these you just combine together and you get 3 plus negative 4, better known as negative 1. These are great questions that you could confirm that you have the right vertex on your calculator. You could graph both the original and the new one you get in y1 and y2, and you should see that they're the same parabola. That would be an excellent way for you to double check that you've done those right. There will be a bonus question on that section, so make sure you try it. Exponents, again for the 3rd time. So the major issue that we had on exponents on the last test were some of you guys did not know what to do with the coefficients, or you didn't handle the coefficients properly. So for number 7, let's talk about these coefficients. They're not raised to any powers. You just have a 21 over 19. So the fraction 20 over 9, 21 over 9 is a fraction that reduces. You can just hit math enter. They both divide by 3, so you end up with 7 over 3. So your true coefficient is a 7 over 3. Now let's talk about the terms, and I wrote way too sloppy here. Oops, that's not an eraser. Let's kind of look at the terms here. We have x's and y's. So one thing I notice is that we have x to the negative 2, and that's going to need to move up to the top. So that's x squared. The other thing I notice is we have y to the 6th over y to the negative 4th. So right there you have a choice. You can either subtract them, or you can move the negative 4 up to the numerator. So either way, you should end up with y to the 10th in the numerator. And that's going to be your final answer for that question. So I think you guys did a fantastic job of what to do with the x's and the y's. Some of you had a little issue with not subtracting properly, so maybe double check in the calculator once in a while, but the coefficients were the major issue. So let's look at number 9. The coefficients in this case do not have any exponents either. They are going to stay exactly where they are, and the coefficient of 5 over 9, nothing happens. It doesn't reduce. But everybody here is negative, and this guy is negative, so basically they just need to move. So the issue we had on the last test is you moved the coefficients by accident. So just watch out for that on this next test. All right, number 11. Everybody, including the coefficients, is going to get the -1 power. So 9 to the -1, and then x to the -3 times -1 will be the +3, and then 7 to the -1, and then y to the -6. So that -1 power got distributed to everybody. And that was the mistake, again, sensing a theme here, guys. You forgot the coefficients. So now you're just going to move everybody who's negative, which is almost everybody. So the 7 is going to come up to the numerator. You can say to the first, that's okay. The x to the third can stay where it's at, and the y to the 6th is going to move to the numerator. But then the 9 to the first gets moved to the denominator. And again, you don't have to put the first power, because we know that. So basically, everybody who was negative moved around. Moved, and moved. Not enough arrows in the world, right? Okay, number 13. Oh boy, guess what you messed up on this one, guys? You forgot the coefficients. So the 1/2 power gets distributed to everybody, including the coefficients. So this is 100 to the 1/2 power, and then y to the 1/2 times 18 is to the 9th power, and then 81 to the 1/2 power, and then x to the 10 times 1/2 would be x to the 5th power. So something you need to remember about your coefficients here, not only did they get the 1/2 power, but these simplify or they reduce. You can just type it in your calculator if you're not sure, but 1/2 power is the same thing as the square root of 100. So this really says 10 over 9, and then we had y to the 9th over x to the 5th. That's what I'm looking for on that question, guys, okay? So that's your exponent section. Once again, third time. We are going to be seeing a bonus question on there as well. All right, here's some new stuff for us. The complex number system. So a few things to remember. Once you get to number 17 here, I need all of your answers to be in standard form, a plus bi form. I need to remember that I is how we represent the square root of -1, and I need to also remember that I squared is equal to -1. Those are the important things for complex number operations. So first thing I see is number 15. They want me to simplify a radical with a negative in it. And the formula that we use for simplifying these radicals is we put our perfect square first. We break it up and we put the -1 in the middle. And then we put the leftover part at the end. So a list of perfect squares you might want to remind yourself of. 1, obviously, but 4, 9, 16, 25, yada, yada, yada. So when I look at 20, 20 does have a perfect square factor. The largest one in this list that divides into 20 is a 4. -1 always goes in the middle for these. And then the leftover part would be 4 times 5 is the other factor for 20. So now we just simply reduce them. You have a better name for the square root of 4, that is a 2. You have a better name for the square root of -1, that is an I, and then the square root of 5 just stays as it is because it doesn't reduce. So that's the pattern you want to use each time. Some of you need to redeem yourselves on the last time you simplified radicals. I think you secretly know what you're doing, guys. 17, for some reason, kids keep getting this one wrong, and they're making it harder than it is. All I want you to do is add. You're just adding the complex numbers together, which means you're going to add the real parts. So 9 plus 4 is a 13. And then you're going to add the imaginary parts together. So 3i plus -9i is -6i. That is all you have to do for this question. Just add the real parts and add the imaginary part, and then stop your work. So that's supposed to be an easy question. So is number 19. But this time, they want you to subtract. I even wrote the word in bold capital letters and everything. So notice there is a subtraction symbol in between these two numbers. So just remember that when you're doing your work. You've got a 9 minus a 4, so that would be a 5. Just watch the imaginary part. This is where the mistakes usually happen. 3i minus negative 9i. Write it down if you're not sure. 3i minus negative 9i. Well, double negatives next to each other become a plus sign. So this becomes a plus 12i. Don't type the I on your calculator, but you can type the coefficients if you really get in a jam. So 17 and 19 should be easy, easy, easy. 21 takes a little bit of extra work because when you multiply numbers together, like we're doing in 21, you do need to remember that you are foiling, you're distributing to everybody. So we start by taking 9 times 4, 36, and then 9 times negative 9i would be negative 81i. And then we keep going. We do 3i multiplied in, so plus 12i. And then 3i times negative 9i is a negative 27, and then I times I would be I squared. So this is where you don't stop until your answer looks like this. It has to look like a plus bi form. So one thing I notice is negative 81 plus 12i, those can combine together. And then the other thing I need to remember is that I squared is really a negative 1. So what we really have here is you have a 36, and then, oh boy, I should be able to add this together, shouldn't I? I think that's a negative 69i. And then here you have, like, okay, I should not skip that step. Here we go. You have a negative 27 times a negative 1. So what you really have at that back number is a plus 27. So then you should be able to combine your real parts together. And your final answer is, let's see, 63 minus 69i. So multiplication takes a little bit of extra work, and we should expect that on our test as well. Now 23, that's a good time, division. In order to divide by a complex number, you need to use the complex conjugate. So I already put parentheses around the denominator so you kind of remember that that's all one number. The complex conjugate almost looks the same, it's like a twin, but the term of I, the imaginary term, has to have the opposite sign. So for you, that would be a 4 minus I. And you need to multiply that by both the numerator and the denominator. So what you end up with is a multiplication problem up here in the numerator. This distributes and becomes a 42 minus 13i. And then down in the denominator, you get this kind of elaborate foiling problem, but some cool things happen. So 4 times 4 is a 16. Oops, I should be using a different color. Time out. Let's use green. So multiplying this together, we're going to get a 16, and then 4 times negative I is a minus 4i, and then 4 plus 4i. That's what we like to see in conjugates. They should cancel in the middle. Careful here though, guys. This is positive times negative, so it's a negative, and then I squared. So now we got to come back through and think about how we simplify this. So these cancel, because they're plus 4i and minus 4i, but this is really a negative 1. So you're really subtracting a negative 1 right here. So when I think about what does that mean for my problem, I have a 42 minus 13i over 16 plus 1, which is a 17. So you're technically supposed to do this, 42 over 17 minus 13 over 17i, because again, in the instructions, it's going to say, write your answer in standard A plus BI form. That, oh, can I not add? That's 52. Oh, Bruzo, back up. Girl. Can't multiply. That's okay. Happens. So this is a 52, and that's a 52, and that's a 52. And that's my final answer. All right, cool beats. So definitely practice that section. This is the only time we've tested it. We have been working on it for about a week, but it's the only time we've tested it. All right, last one here. These are awesome problems because you should be able to walk away and know that you got it right. I want you to solve this both algebraically and through graphing. So we're going to start the algebraic one. We're going to square both sides. And we're going to get x plus 2 equals, now don't forget, this is really an x minus 4 times another x minus 4. So you need to FOIL that out. So distributing the x and distributing the negative 4, we end up with x plus 2 equals x squared minus 4x minus another 4x, they do not cancel here, and then a plus 16. you have a quadratic, so you need to bring everything to one side. I'm going to subtract the x over here. I'm also going to subtract the 2 over here. And then our equation becomes 0 equals x squared. Got a lot of simplifying going on here in the middle, guys. You got -4, -4, -1. So if you combine all those together, you get a minus 9x. And then plus 14. And I promise you'll always get quadratics that factor when the question produces a quadratic. So now you're going to solve this by factoring. I'm looking for multiples of 14, or sorry, factors of 14. They're also going to have to add up to -9. So what if we used a -7 and a -2? Now you have to solve your factors. You have to say x plus, x minus 7 equals 0. So that means x equals 7. And x minus, I skipped a step. X minus 2 equals 0. Uh-oh, someone's calling me. So x equals 2. And there are your two solutions. Maybe. We didn't actually check any. Here's what's going to happen. We're going to find out that this one is extraneous, because when we go to graph this on our calculator, so we're going to enter these into y1 and y2. You're going to see, and I'm going to give you an Abruzzo rendition so you know it's going to be awful. Let's see here. 7, 3. It's going to look like this. And then the red line. You're going to use your calculator, guys. Don't panic, because it's going to look way better than what I just did. You're going to notice there's only one intersection point at x equals 7. So that is another way for you to check that this x equals 2 doesn't work. At x equals 2, you don't see an intersection of those two functions. And that's why it's extraneous graphically. If you plugged them into the original problem, you would have got the square root of 2 plus 2 equals 2 minus 4. And you know what, guys? The square root of 4 does not equal the equal -2. So that's a no. All right, good luck, everybody. Final exam's coming up next. Hope your grade is where you want it to be.